Hi, this is a lesson about using your calculator to solve certain trig problems. And so, as much as we all love the unit circle, there are certain angles that exist but are not labeled on the unit circle. So there are famous angles, your Nicolas Cages, if you will, of angles that everybody knows and recognizes, like, pi over 6, pi over 3, pi over 4, and all their relatives, right? Those are all angles that we know, love, recognize, get swarmed by the paparazzi. But there are other angles, like this one I have in blue here. It's a nice angle. It's lovely. It's in quadrant 1. But, no one really knows what it is. No one knows its name. And even if we did tell you and we said, oh, that's good old, pi over 12 or pi over 14, you say, oh, great. I don't know anything about that guy. Well, the calculator is there to save the day and help you know about that guy. So there's a little space, if you printed the notes, there's a little space at the top of your notes, and if you're writing your own notes, that's absolutely great, good for you. But I would like you to just take some time and set this chart up. This chart is going to solve all the things, okay? So if you need to pause the video so you can look at the screen for a little while, please do so. And so what we really are going to do with all of these lesser famous angles, the things that are not related to our families, the 30, the 60, the 45 degree families, with angles that are not related to those famous families. They're not the Kardashians. They live on the unit circle, but they're not labeled on the unit circle. With all of those angles, we are going to ask ourselves, is this a question where I know the angle, or am I trying to solve to find the angle? And then we're also going to ask ourselves, is this one of the 3 primary trig functions, like the ones that have buttons on my calculator, or is this like the ones that don't have buttons on my calculator? Okay, so those are the 2 questions that are represented. First over here, know the angle, solving for the angle, and then over here, main guy, not so main guy. All right, so that's the idea. If I talked enough time that you have the chart set up, well, fantastic, let's go, okay? So we're gonna do each of the 4 cases and you'll be completely solid, okay? So when you know the angle, the strategy is going to be just type it in. That's our favorite one, okay? I'm going to make a little note here. Actually, I'm gonna put it in the upper, like this little box that doesn't have anything. We should always make sure our calculator is in the right mode, especially if our stinky sibling borrowed our calculator and put it back without telling us, and they are in physics or something, or in calculus. They might have messed up our calculator settings. So we always would like to double check the mode. Mode is in red on my screen right now, and notice that I have it on degree. So there's radian and there's degree. So right now I'm in degree. If I have a question that's in radians, I'm going to go to radians, okay? But I need to make sure that I'm aware of what mode my calculator is in, okay? So know the angle, we're just going to type it in. We're going to make sure that we're in the appropriate mode. If we know the angle, but it's one of the lesser known trig functions, we are going to use the idea of a reciprocal. So that would be, for example, if I had something like cosecant of 37 degrees. Now, I would love to just type that in, like the last category, right? The last category would be, for example, something like if I just had sine of 48 degrees, right? I can just type that just how it looks, okay? But cosecant, there's no cosecant button. So I need to remember that cosecant is the reciprocal of sine. And so I can just then find the value of sine of 37 degrees and then flip it, right? Find the reciprocal. Yay! Now, when I'm solving to find the angle, that would be, for example, something like I have sine of blank, sine of theta, that's my variable, is 0.3. Okay, so what I want to do is find out what theta is, so I need to get rid of sine. So I need to take the inverse sign of both sides of my equation. So what I actually end up typing in, oh, bad planning ahead. I did not leave myself enough room. Okay, so then I would inverse sign both sides of that equation. Theta would be by itself, my variable would be isolated. And what I type into my calculator is inverse sign of my number, and the result of that would be the angle that I'm trying to find. So the overall idea for this problem type is use an inverse. Okay, so I've got type it in, I've got use the reciprocal, I've got inverse. Now, this last category is the spicy meatball of the whole situation, my friends. So this last category is one where I don't know the angle. And in addition to that, not only do I not know the angle, I also am using one of these lesser trig functions. They aren't really lesser, I just need a name, okay? So in this case, you're going to do a combo. You're going to use the inverse and you're going to use the reciprocal. But like a lot of things in math, the order matters. And rather than memorizing, I would advise that you just kind of know what the logic is. So my example here would be, let's say we had cotangent of some angle. So cotangent of my unknown angle theta is 1.2. Now I don't love working with cotangent, so I'm going to take the reciprocal of both sides. The reciprocal of cotangent is tangent, and the reciprocal of that number would be 1 over that number. That's what we mean by reciprocal. And then if I've now turned it into this kind of problem, right? It's one of the main trig functions now. Here's tangent. And I just can inverse to get the angle alone. But if you look at this line that I'm writing right now, you see that I did two different ideas. I have the inverse and I have a reciprocal. But it's not really like this kind of reciprocal, right? It's a reciprocal of the number and then the inverse function, okay? Now again, I really recommend that you go through these little baby steps on the way so that you don't get yourself messed up in your head, okay? That fourth case is the spicy meatball of the whole thing, okay? So that's our organizer, okay? And we're going to use that organizer to help us do these problems. Now, in this first set of 6 problems, there actually are 2 different categories that we're practicing. There's know the angle, and it's one of the primary trig functions. And then there's know the angle, but it's one of the other 3, the secondary trig functions, okay? So with know the angle, what was it that we wanted to do? You're right, we just want to type it in. And then over here, this is know the angle, but I don't have a button for these things. Like I can't just type secant 32. So the key over here is going to be to use the reciprocal. So the reciprocal of cosecant is sine. And so that's what I'm going to type in. Look at all of these questions as a collection. What mode do I want to be in? I hope you said degree. That's what all those little circles mean, right? So if everything's in degrees, we should be in degrees. So I would like you to take these 6 questions to your calculator, do the problems, and then come back and see how you did. Don't cheat and just watch my answers. You're not going to learn that way. Okay, pause and try. Okay, here are the numerical answers. And hopefully you saw that this entire page was all about 32 degrees. So when I found the sine of 32, if I moved right over to here, that gave me a shortcut, right? Or it gave me part of the answer for the next one, right? So I could just do 1 over my answer from sine of 32 and get the cosecant. If you didn't see that, it's no big deal, okay? But understand that these 3, you just typed in, just like they look on the page. For these 3, like for the secant, you had to do 1 over cosine of 32. And for cotangent, you had to do 1 over tangent of 32. Because the case that we were in was this guy right here, right? This reciprocal one. All right, this problem. Now, I have already labeled that it is solving to find the angle in a primary trig function. So we can see that the angle is what's missing, right? The thing next to the trig function, like if I write sine of x, x there would be the angle. If I write sine of alpha, alpha is the angle. If I write cosine of beta, beta is the angle. If I write tangent of heart, heart is the angle, okay? So whatever the trig function applies to, that is my angle. So I have the sine of unknown angle equals a number. So I'm finding the angle because that's not known. And primary is when I have sine or cosine or tangent. Okay, so in order to do this problem, I'm going to recognize that I am in this category right now, and that means I find it with an inverse. Now I'm going to write this out a little bit more than when I was explaining it on the chart. I'm going to show my work a little bit more, if you will. So the original equation is in green, and what I've done is I'm taking the inverse sine of the green equation, right? And you do the same thing to both sides when you're doing algebra. So sine and inverse sine are inverse of each other, just like the name suggests. So this would give me theta is the inverse sine of negative 0.7. Now, there is a little bit of a tricky aspect to this. So if you think about the fact that it says here for all angles between 0 and 2 pi, our calculator is just going to give us one answer here. And we have to be smarter than all things considered, okay? So I also am noting here that this means we are in radians because it's between 0 and 2 pi. So when I go to my calculator right now, I'm going to switch over to radian mode. At least theoretically I am. Sometimes things lag, you know. Okay? And then we're going to do inverse sine of negative 0.7. Okay, and it tells me this angle, negative 0.775. Okay, I'm going to round to 3 decimal places like we do in AP Calculus. And so I know that there's an angle of negative 0.775 radians that has that sine value. Now think about your unit circle. Negative means we're rotating this way. So there's a spot here that has a sine value of negative 0.7, but it's said to find all angles going around this way from 0 to 2 pi. So two things. First thing is I need to name this angle in a positive direction rather than in a negative direction. That's easy enough to do. I can just say, well, that's pi, but not that last little sliver. I just said pi instead of 2 pi. That's 2 pi instead of that last little sliver. So 2 pi, but not the last little sliver. So 2 pi minus 0.775 tells me that another name for this location, a coterminal angle, if you will, is 5.508. However, it's even more tricky than that because there's another spot over here that has the same sine value. And you know this from our work with the famous angles. It works the same way as the non-famous angles, right? So just another place. And this reference angle is the amount that we found here. So if that part of our bow tie is 0.775 radians, this part is 0.775 radians, which means this rotation to get to that blue spot is pi plus 0.775 radians. So my final answers are going to be these two numbers. And I already found a decimal estimate for this one. Hey, I thought I paused and I didn't. My starter stopped working. I'm sorry about that big gap. Okay, so 2 pi minus that little bit and pi plus that little bit. Oh, good thing I wasn't like yelling at the dog or something in the middle of there. Okay, let's take a look at example 3. Okay, so I jumped ahead a little trying to make up for my leg there. So we would inverse cosine both sides of this equation. And we find out that the angle that my calculator is going to tell me about is 1.286. But again, these directions say to find all the answers between 0 and 2 pi. So in addition to this location, another place that has the same cosine value is going to be down here. Okay, we know this from our unit circle understanding, right? So cosine being a positive number happens in quadrants 1 and 4. So in this previous question, sine was equal to a negative number. That happens in quadrants 3 and 4. So you have to think about what other quadrant is going to have the matching value. Okay, it's going to be straight across sometimes, but sometimes also diagonal, right? Tangent's weird. Okay, so we get this angle of 1.286. That's going directly to here. It said between 0 and 2 pi, so I can't go the negative way because it says between 0 and 2 pi. So my other one has to go all the way to here. So that's the whole thing except for that reference angle. So 2 pi minus 1.286 is going to be my other angle. 2 pi minus my reference angle gives me 4.997. So these two values of theta are in between 0 and 6.28, and they give a cosine value as listed. The next three are for you to try. I will, when you come back, I will have answers, and you will too. Okay, here are solutions. I've left exact solutions, generally speaking, in a blue box, and the decimals I put in red. So for each of these, you do the inverse because you're solving for an angle, and then you get one of the answers, and then you have to think about your unit circle and where the other angle with the same trig value would be. So notice that for number 1, for tangent being negative, tangent would be negative in quadrants 2 and 4. So find the two things that are in the same not famous family, okay? And then in number 2, cosine being a positive number is going to happen in quadrants 1 and 4. So we are going to find the same reference angle, but in each of those quadrants respectively. And then the tangent being 0 actually is a famous angle. So I hope that you knew that that happened at 0 and pi. Those are just some quadrantal angles. Okay, these next three are ones where a lot is happening. So it just says to find, this is the category of finding the angle with the lesser known functions. So this is the 4th category. And so it is the most tricky. The heading still said between 0 and 2 pi. So we're still solving in radians. And because it says 0 to 2 pi, we're going to find multiple angles. Okay, let's walk through at least one or two of these together. Okay, so first one, I see that it's cotangent. I see that I'm missing an angle. So I'm going to remember that it was advised in that chart to kind of walk it through like baby step. So first thing, reciprocal both sides. Okay, now you might not like having a decimal inside of a fraction. I know that that's making me have the heebie-jeebies. So let's see if maybe we want to write that a little differently and just do the arithmetic on that side. So about negative 2.94117 blah blah is what I have. I'm going to keep that whole number on my calculator screen so that when I inverse tangent, I'm just going to say inverse tangent of the previous answer. So I keep all that decimal place of accuracy. So inverse tangent of that answer gives me that my angle in radians is about 1.243 radians. So I'm going to make the decision right now that we're not doing number 5. So I need this space. And the video's getting a little long, yeah? Okay, so 1.243 radians would be about here. And cotangent is, oops, maybe it's not about there. Let me think for a sec. Oh, I had a mistake because I didn't write a negative sign. Okay, let's go back and fix that. Okay, this makes more sense. So tangent is negative 1.243. Cotangent is a negative number, is what I was given at the start. And I know that that means I need an angle in this quadrant, but also the same reference angle, but in this quadrant. Oh, I'm such a bad drawer. You guys must miss Mrs. Fry. Okay, so this angle is going to be like going all the way to pi, but not that last part, not this part. Okay, so I need pi minus 1.243. I also need all the way around, like to here, but not this last part. So 2 pi minus 1.243. Those are going to be my two angles. So those are the two decimal values I got with those computations, okay? I'd like you to try, what would I like you to try? I think I'm going to have you try the last three on the page, so 7, 8, and 9. Okay, here are those last three. It'll take you a little bit of doing, but come back when you're done and check your answers. Okay, I didn't do the final step of just typing in the part that's in red. I figured you got that, okay? But for 7 and 9, these were the fourth category, so you needed to use the reciprocal and the inverse. For number 8, this one just required using the inverse, because cosine, we have a button for that, okay? And then for each of them, you just need to think about what quadrant should I be in. So for example, if cosecant is negative, your solutions need to be in quadrants 3 and 4, and they need to have the same reference angle. The reference angle is 0.238 radians. In number 8, cosine is negative. Cosine is negative in quadrants 2 and 3. So you need to take the angle that they give you on the calculator, and then you also need to figure out how do I end up landing in quadrant 3 with that same reference angle, the same bow tie angle of 1.896. So it's all the way around, but not the 1.896. And then number 9, cotangent being negative means tangent's negative, and tangent is negative in quadrants 2 and 4. This is tricky stuff, okay? So just keep practicing and make sure that you're reaching out and using your resources if you're having a hard time with this. Thanks.